All right, 7.1 weathering. Make sure you guys are checking out the vocab here. There will be a vocab quiz, but I'm not giving you practice quizzes and stuff like I have in the past. You guys need to get this stuff on your own. All right? All right, because I'm trying to push you to do a little bit more on your own. All right. Okay, mechanical weathering. Weathering is a process in which material on Earth surface breaks down and changes. Mechanical weathering is a type of weathering in which rocks and minerals break down into smaller pieces. This process is also called physical weathering. Mechanical weathering does not involve any change in rock's composition, only changes in the size and shape of a rock. A variety of factors are involved in mechanical weathering, including change in temperature and pressure. All right, so the effects of temperature. The big one here is frost wedging. And you can see down here how it's showing this rock. But let me I don't know how well I can draw anymore on this pad, but I'm going to try. Here's a rock, okay? And in this rock, I get a crack, all right? There's a little crevice in this rock. When it rains, I change colors. When it rains, the rain comes down, and water seeps into this crack. Okay. Now, on a normal summer, spring, fall day, nothing's going on. But just like the weather we've had in the past few days here, when it rains and this water gets in here and it freezes, remember, water is the only substance we know that when it freezes, it expands. Okay. So what happens is as this freezes, it's going to force this rock. It's going to push it apart. When that gets pushed apart, the crack is going to get a little deeper and a little bit wider because of it being pushed apart. Over a continual process of this, you get a rock that looks like this down here. Where these cracks form, water gets in, it freezes, it expands, and it almost looks like a loaf of bread that's been sliced. Okay. This is frost wedging. Frost wedging is what goes on mostly around here in these northern states. We get a lot of frost wedging. Okay. The effects of pressure. Another factor involved in mechanical weathering is pressure. Roots and trees and other plants can exert pressures on rocks as they wedge themselves into cracks. This is biological weathering. All right, it's another mechanical weathering. And in this case, let's draw a rock again. And when I'm drawing this rock, let's think of something huge, like a boulder or whatever, or something like this picture here. What happens is over time we get these little cracks, and if we have I got the right colors sitting here. Maybe. Oh, my cord's in the way here. So we get a tree that grows here, or plants. It could be plants. It could be trees. Trees are easier for me to draw, maybe. I don't know. Here's a tree. All right. Basic little tree. And the roots of the tree get down in here in these cracks. And as they grow, they do the same thing that the frost wedging does. It causes this to be pushed apart. As it gets pushed apart, the cracks get deeper and they get wider. And eventually, just like with frost wedging, it's going to bust this rock into pieces. And that's what's going on right here in this picture. This is a biological weathering, okay? Root wedging, I guess, is the word I'm thinking of. Root wedging. All right, now then we have exfoliation. And on these big rocks like this, I'm going to try to draw on this and see what happens. What's going on here is this rock, internal rock, is cooler. Okay. But the rock up here where the sun's beating down, it heats up and it expands. Thermal expansion. You should remember this from physical science. Thermal expansion. As this rock heats up, it expands. And it causes almost like almost like an onion. This top layer, this top little bit that heats up is going to expand. When it expands, it loosens up. It becomes loose. It cracks off the rock underneath and it becomes loose. And this eventually will fall off of here due to gravity, moisture. Water gets in here, freezes, lifts it up. When it drops back down, it'll fall off. All right. And that's common. That's a common on mountains and that. It's common to have these exfoliation domes. Just like you exfoliate your face, rocks exfoliate that outer layer. They push it off. All right. Chemical weathering. Now remember, when there's a chemical change, I end up with something different than what I start with. Okay, so chemical weathering is a process by which rocks and minerals undergo changes in their composition. All right, changes in their composition. Agents of chemical weathering include water, oxygen, carbon dioxide, and acid. These interactions of these agents with the rock can cause some of the substance to dissolve and some new minerals to form. The new minerals have properties different than those that were in the original rock. For example, iron often combines with oxygen to form iron oxide, such as hematite. Iron oxide is a form of rust. Hematite is an orange material. Okay? So chemical weathering. When I have chemical weathering, I do not have the same material that I start with. I have new material. That's what this is telling us. When you go through a chemical change, when it goes through a chemical change, you have new substances. All right, we're going to end up with new substances. All right. And then it's going to tell us about the effect of water. Make sure you guys are reading this stuff. I cannot push that enough. I know most of you aren't reading. You have to read this stuff. The effect of water, the effect of oxygen, how both of these affect chemical weathering. All right. Carbon dioxide and chemical weathering, and acid and chemical weathering. All right. The weight of weathering, the rate of weathering. Rate of weathering. This has to do with what kind of zones are, I think in biology class, what kind of niche or biome, these biomes, all right? Different biomes have different rates of chemical weathering, all right? The more humid it is, the more weathering is affected. The more vegetation, the more rainfall, warmer temperatures. These all produce different types of weathering or different rates of weathering of how fast it happens. Rates of physical weathering, they're going to be the same way. Remember, physical weathering is stuff like frost wedging. It's slow process. Frost wedging is a slow process. It takes years and years and years for this to be accomplished, as it does down here too. And that depends on what type of rock we're talking about. We're talking about granite. Are we talking about limestone? Are we talking about sandstone? Everything, all different types of stone weather at different rates. All right, and in different situations, different climates and that. The more surface area a rock has, the more surface area, the faster it'll break down. Think about this. If you take an ice cube and you put it in a glass of water, it's going to melt. It breaks down, okay? If I take an ice cube and I shatter it and I throw it in the water, it's going to melt much quicker because there is more surface area. Make sure you know the effects of surface area. All right. Also, the topography. If it's a flat surface and there's no slopes, no hills, no slopes, it's going to take it longer to weather. If it's on a slope, it'll break down a lot easier, like an exfoliation. Hopefully, this lecture is going to help you with this section and the homework.